Think about concrete. It's literally the foundation of our entire civilization. Our skyscrapers, our bridges, our homes. It is the most widely used material on the entire planet. But here's what most people don't realize. It has a universal, hidden flaw, one that begins the very moment it gets hard. See, every single concrete structure, no matter how strong we think it is, eventually cracks. It's just an unavoidable part of its life. And these tiny fissures, they might look harmless at first, but they're basically open doors for all the bad stuff, water, salts, chemicals, to get inside and start rotting the structure from within. Get this, 750,000. That's how many new potholes were reported in the UK in 2023 alone. And every single one of those is just a tiny concrete crack that eventually lost the fight against time and traffic. But this isn't just about a bumpy ride to work. That number is a massive warning sign of a much bigger decay happening all around us.
Right? We depend on this stuff for our safety, for our economy, for basically everything, and yet we've just kind of accepted that it's fundamentally fragile. We're stuck in this constant and incredibly expensive cycle of patching things up, repairing them, and then replacing them. But what if we've been looking at this whole problem the wrong way? The real solution isn't just a better patch or a stronger chemical sealant. The real breakthrough, and this is the part that changes everything, is the idea of embedding a biological immune system right into the concrete itself, creating a material that can actively heal its own wounds from the inside out.
And this brings us to what you could call the central paradox of concrete. The challenge was never about preventing cracks. That's basically impossible. The real challenge was figuring out how to make those cracks irrelevant.
And what's wild is that concrete already has this tiny natural ability to heal itself. It's a process called autogenous healing. It can fix cracks that are thinner than a human hair. But the real game changer, the thing we're really digging into, is autonomous healing, an engineered process that can seal much bigger gaps, essentially supercharging this natural ability.
So, how do you do that? To pull this off, scientists turn to a very, very unlikely ally. Not some new chemical or a fancy synthetic polymer, but something way more fundamental. Something that's been perfecting the art of building for billions of years. Life itself.
This is bacterial self-healing concrete. And the concept is it's incredible. We're talking about mixing millions of tiny, living construction workers directly into the concrete. They just hang out dormant, waiting for the exact moment they're needed, creating this proactive, built-in repair system that just springs to life on demand.
Okay, but the big question is, how do you keep bacteria alive inside the super harsh alkaline world of concrete? Well, the solution is genius. Scientists encapsulate bacterial spores, usually from the Bacillus family, inside these tiny porous clay particles. These little capsules act like life rafts, protecting the bacteria and a little stash of food, keeping them dormant like seeds in the soil, just waiting for the right conditions to wake up.
So, how do these bacteria actually build? This is where we get to see microorganisms performing microscopic construction work, turning a structural flaw into a permanent fix.
The whole process is so elegantly simple. First, a crack forms from stress or weather. Then, water, which is the enemy of regular concrete, seeps in. But here, that water is the trigger. It breaks open those little protective capsules and wakes up the dormant bacteria. The bacteria immediately start eating their packed lunch, which is calcium lactate. And through their natural metabolic process, they excrete calcium carbonate. In other words, limestone. That limestone hardens, fills the crack, and boom, the concrete's integrity is restored.
And here is the visual proof. I mean, you can see it with your own eyes. On the left, you've got a standard crack in a piece of concrete. On the right, after just a few weeks, that exact same crack is visibly sealed up, filled in by the brand new limestone the bacteria created. The empty space is gone, which stops more water from getting in and actually restores the material's strength.
And this isn't just a cosmetic fix, not at all. The data proves it. Through a process they call biomineralization, which is literally life-creating minerals, concrete that uses a bacteria called Bacillus subtilis showed a 25% reduction in how much water it absorbs, and a 21% reduction in empty voids. This makes the material demonstrably more durable against the very things that cause it to decay in the first place.
Now, to be fair, bacteria aren't the only approach people are looking at. Researchers are exploring polymer microcapsules that burst and release a kind of glue, and even shape memory alloys that physically pull cracks closed. But the bacterial method is unique. It doesn't just patch the problem, it actively rebuilds the structure with new limestone. It's integrating a living, regenerative system right into the material itself.
And this is where things get really, really interesting. This isn't just some small improvement. It represents a fundamental paradigm shift in how we think about construction and maintenance. We're moving from a passive model of building things to an active biological one.
This quote from Professor Hank Jonkers, who's a real pioneer in this field, just says it all. We are blurring the lines between inorganic building materials and living biological systems. It's like we're creating a hybrid material that mimics the healing ability of living tissue. You know, like how a bone or our skin heals.
So what does all this mean in the real world? It means this: 60.3%. That is the average reduction in long-term maintenance costs when you use self-healing concrete. By pretty much eliminating the need for constant, labor-intensive repairs, the economic savings are just absolutely massive. And the long-term benefit is even more profound. You know, most of our current infrastructure is designed to last maybe 50 years. Some advanced materials might push that to a century. But with self-healing capabilities, we are looking at structures that could realistically last over 150 years. They could serve generations longer than anything we build today. So the takeaway here is pretty clear. This technology leads to a future where our infrastructure is safer, simply because it's more durable. It's also way more sustainable, because we're not constantly having to produce new cement for repairs, which is a huge source of CO2 emissions. And it could drastically reduce that incredibly costly cycle of decay and replacement that defines so much of our world today. I mean, this really just opens up a whole new world of possibilities. We've taken the most common building block of the modern world and given it the ability to heal. It really forces us to ask a final, provocative question. If our concrete can be alive, what on earth will we build with next?
Think about our cities for a moment. They're never truly still, are they? There's this constant thrumming energy. Millions of people walking, running, driving. A symphony of motion. But what if all that movement, all that energy we create just by existing, wasn't just lost? You know, when you look at a bustling train station or a packed city square, what do you see? You see people, you see movement. But a very clever group of scientists and engineers, they see something completely different. They see an untapped, renewable power source hiding right there in plain sight. And here's the wild part. Every single time your foot hits the ground, you release this tiny little burst of kinetic energy. Normally, that energy just vanishes, soaked up by the concrete. But what if we could actually grab it? That's exactly where this incredible idea begins. I know, it sounds like something straight out of science fiction, right? How on earth do you turn the simple force of a footfall into actual, usable electricity? You know, the kind that can power a light or charge your phone, or maybe even feed back into the city grid? Okay, let's get into it. To really understand how a simple step can become a flicker of light, we need to rewind the clock a little. We're going back to a fascinating discovery from 1880, made by the Curie brothers. It's a scientific principle that's all around us, even if we never notice it. The whole thing hinges on a principle called piezoelectricity. Now that's a mouthful, I know, but it comes from a Greek word, paisin, which just means to squeeze or press. And that's literally all it is. When you squeeze certain materials, they create an electrical charge. It's that simple. Let's break this down. So take a look here. You've got this special ceramic material. Inside, it's got a bunch of positive and negative charges, all nicely balanced. But when you squeeze it, when you apply pressure, you knock that balance all out of whack. That imbalance creates a voltage, and boom, just like that, you have an electric current. And you've actually seen this happen 1,000 times without even realizing it. Think about one of those butane lighters with the little clicky button. When you push that button, you're causing a tiny hammer to smack a piezoelectric crystal. That impact generates a high voltage spark, and that's what ignites the gas. It's the exact same science, just on a much smaller scale. So if we put it all together, it's a pretty elegant four-step process. First, your footstep applies pressure. Second, that pressure deforms the crystal inside. Third, that deformation creates a little burst of alternating current, or AC. And finally, since most of our gadgets run on direct current, or DC, that electricity gets converted and then either stored in a battery or used right away. Step, squeeze, spark, store. All right, so we've got the science locked down. Now for the really cool part. Let's look at how this amazing principle is making the jump from the laboratory to the very sidewalks we walk on every single day. I love this quote from Lawrence Kemble Cook, who's a real pioneer in this space. It puts everything into perspective, doesn't it? This isn't some overnight magic bullet. Just like solar power, it's a technology that's on a journey, slowly but surely getting better, more efficient, and more affordable year by year. And this is a perfect illustration of that journey from an idea to reality. On the left, you see the guts of the machine, all the complex engineering that makes it work. But on the right, you see the final product, these sleek, simple tiles being laid down. All of that amazing physics is happening right under your feet, completely hidden. So where are these smart surfaces actually popping up? Well, the most logical places are the ones with the most motion, right? High traffic areas where you're guaranteed a constant stream of footsteps or cars. We're talking airports, subway stations, shopping malls. They're being used to power things like LED lights, digital signs, and even data collecting sensors. Okay, but as exciting as all this is, let's be realistic. The road to a world powered by our own footsteps isn't perfectly smooth. There are some pretty big bumps and challenges we need to figure out before this tech can really go mainstream. Let's just look at the balance sheet here. On the one hand, yes, it's a renewable energy source that lowers our carbon footprint. Awesome. But on the other hand, the upfront cost to install this stuff is really high, and its performance is totally dependent on having tons of people walking on it. Plus, and this is a big one, the energy output for now is still way lower than what you'd get from solar or wind. And to put a real number on that cost problem, you're looking at anywhere from $500 to $2,000 per square meter. That is a massive upfront investment compared to just pouring regular concrete, and it's probably the single biggest hurdle to seeing this everywhere. And here's a fantastic reality check. DARPA, the US military's high-tech research agency, actually tried to build this technology right into soldiers' boots. The idea was to power their gear on the move, but they had to scrap the project. Why? Well, it was impractical, but more importantly, it was just uncomfortable. It actually made it harder for the soldiers to walk, which completely defeated the purpose. So yeah, there are some serious hurdles. But if you just think of this as a direct competitor to solar or wind, I think you're kind of missing the bigger picture. This is where the true potential really starts to open up, especially when we think beyond just our own 2 feet. Get ready for this, because this is where the scale just becomes mind-boggling. A study out of the University of California estimated that just 1 mile of a single highway lane could generate over 72,000 kilowatt hours a year from the weight of cars alone. Now, if you look at heavy trucks, that number skyrockets to over 900,000. We're not talking about powering a few light bulbs anymore. This is a serious amount of energy. And looking forward, this technology is about so much more than just making electricity. It's about building smarter cities. Imagine these floors collecting real-time data on how people move, helping city planners design better, more efficient public spaces. And scientists are already cooking up new materials, like tiny nanogenerators, that promise to make this tech even more powerful. So, the next time you're walking through a busy city, just think about it. Think about the incredible invisible energy that's all around you in that motion. This technology really just asks one simple but really powerful question. What if we could actually harness it? What if every single step we take could also be a small step towards a more sustainable world? We live in a world that we've built, literally, from the ground up. But in creating our concrete kingdoms, we've pretty much evicted the one thing that actually keeps us alive: nature. So the question isn't if we can survive in these jungles of steel and glass anymore, it's how do we engineer a way for nature to move back in? It sounds like a question straight out of science fiction, doesn't it? How do you plant a forest on a skyscraper? But here's what most people don't realize. This isn't a fantasy. It's one of the most urgent architectural puzzles of our time. How do you take an entire living ecosystem and graft it onto the side of a modern high-rise? Okay, let's get into it. So you might be asking, why would anyone go to all this trouble in the first place? Well, to get that, we need to talk about a huge problem that is, quite literally, cooking every major city on Earth. We have all felt this. You walk outside on a summer day and just get hit with a blast of heat radiating off the pavement. That's called the urban heat island effect. All that concrete, all that asphalt and steel, it just soaks up the sun's energy all day and then releases it back at night, turning our cities into these gigantic ovens. And this isn't just uncomfortable. It sends our energy demand through the roof as we all blast the air conditioning just to stay sane. So the solution is, surprisingly, pretty simple on paper. You fight concrete with chlorophyll. Now, this is where it gets really interesting because the benefits just cascade. It's not just about one building. You start on a building scale, right? You improve its energy efficiency, you filter its air, but then when you do that across a whole neighborhood, you start to cool the entire city on an urban scale. You're cleaning the air for everyone, creating little habitats. It's a solution that scales from a single apartment balcony all the way up to an entire skyline. So we get the problem, and we know that putting up green walls can help. But one team over in Milan, Italy, they decided to take that idea and push it to its absolute logical extreme. And this is it. This is the Bosco Verticale, which literally just means vertical forest. It was finished back in 2014, and it's probably the most famous example of this radical idea brought to life. And you can see this is not just a building with a couple of potted plants on the balcony. No, this is a complete reinvention of what a residential tower can even be. The sheer scale of this is honestly a little hard to wrap your head around. We are talking about 2 towers, the taller one stretching up 117 meters, and they're covered in over 900 trees and something like 20,000 other plants. This isn't just a cool building designed by Stefano Boeri Architetti, it's a living, breathing ecosystem, literally grafted onto the heart of a major European city. It's absolutely stunning to look at, for sure, but the real magic, the true genius, is totally hidden from view. This isn't just a building with some trees on it, it's an incredibly complex, meticulously engineered living machine. So, how on earth did they pull it off?
I mean, it's the first question that pops into your head, right? It's one thing to use a crane to lift a tree up to the 20th floor. It is another thing entirely to keep it alive and thriving year after year through brutal winds, scorching sun, and freezing cold winters. The secret really starts with the skeleton of the building itself. The greenery was not an afterthought. The entire structure was designed from day one to hold a forest. Each one of these cantilevered terraces is basically a massive reinforced concrete planter, sticking out 3.3 meters, engineered specifically to handle the immense weight of fully grown trees and all their roots. And the team behind this wasn't just gardening, this was high-stakes botanical science. They didn't just pick plants that looked pretty, they meticulously selected over 90 different species based on a brutal checklist. Could it survive intense winds? Check. Could it handle pests and constant pruning? Check. Even the placement was a strategic game. Sun-loving species like holly oaks were put on the south-facing side, while plants that prefer the shade went on the north. Every single plant is in its perfect engineered home. So if the terraces are the skeleton, the irrigation system is the building's circulatory system. It's this incredibly sophisticated, computer-controlled network of drip lines that runs through the whole structure, like veins and arteries, delivering a precisely calculated dose of water and nutrients to each and every plant. It is, quite literally, a life support system for a vertical ecosystem. But of course, a living machine needs constant care, and this is where things get really, really complicated. For routine stuff, teams actually go through the apartments a few times a year. But for the big jobs, a specialized team of flying gardeners has to rappel down the side of the building from a crane on the roof. They perform this very specific kind of green pruning in the summer, which lets them shape the forest and manage its growth without actually hurting the trees.
So you have this incredible, complicated, and, let's be honest, very expensive system. Which brings us to the big question. Was it actually worth it? Does the green payoff justify the price tag? Well, first, the impact on energy is real, and it's measurable. The combination of those deep terraces and the dense leaves provides so much natural shade that it cuts the building's electricity needs for cooling by 7.5% every single year. In a world with soaring energy costs, that is a massive win. But like any system, there are trade-offs, and this is a big one. That cooling benefit comes at a cost. During the hottest summer months, each tree on that building needs, on average, 1.4 cubic meters of water. That is a lot of a very precious resource that has to be pumped up that building. And then you have the human cost, which the research team put pretty bluntly. They found that just pruning one tree on the building is 5 times more expensive and time-consuming than doing the same job on the exact same tree at ground level. That really hammers home the incredible logistical and financial commitment it takes to keep this forest in the sky alive. So you've got these clear benefits, but you've also got these very real, very steep challenges. Where does that leave us? Is Bosco Verticale just a beautiful, one-of-a-kind experiment, or is it actually a glimpse into the future of our cities?
The answer, it seems, is that this was just the beginning. Bosco Verticali was never meant to be the endpoint. It was the proof of concept. And now, fueled by this global push for sustainability, cities all over the world are looking at this project as a blueprint, trying to figure out how to weave nature back into their own concrete landscapes. And that really brings us right back to where we started. We've proven that it can be done. We know the benefits are real, and we now understand the staggering costs. The technology is there, the ambition is there. So the real question isn't whether we can turn our cities into forests, it's whether we have the will to actually do it. Are we ready to re-engineer our world?
Thanks for watching. Support BioVellum by liking, subscribing, and sharing. Let's explore the secrets of nature together.